The sight of the starry night sky is simply overwhelming. Observing the thousands of shimmering objects in the coming months might make one think the cosmos has gained an extra star, but that's not the case. As announced by NASA, it will be the result of a spectacular natural show, once again revealing the elemental forces of the universe. But what exactly is it? Why will T Coronae Borealis shine 1,000 times brighter than before? Will this celestial body plunge its surroundings into disaster with a devastating explosion? Or is the breathtaking magic of space not always tied to chaos and destruction? Modern observers, highly complex telescopes, and a team of renowned astronomers are all unnecessary to marvel at the overwhelming transformation that T Coronae Borealis will soon undergo. In the constellation Coronae Borealis, approximately 2,700 light-years away from Earth, T CrB will undergo a dazzling change that we may witness with the naked eye. Anyone with a standard binocular can admire the star for just over a week before it fades back into the darkness of space for the next 80 years. Strictly speaking, the term star is not accurate. In reality, we are observing a binary star system composed of an extended red giant and a compact white dwarf. Experts define red giants as aged stars the size of a solar mass, where hydrogen fusion in the core has ceased due to lack of fuel. White dwarfs, in turn, are the hot cores left behind when the outer shell is expelled in the star's final stages of development. The dynamic nature of the binary stars in the case of T CrB becomes evident when looking at the distance between the two celestial bodies, estimated at half an astronomical unit, about 75 million kilometers. The objects take 228 days to orbit each other, and due to their spatial configuration, matter from the red giant flows towards the white dwarf. This brings us to why it will provide a spectacular phenomenon in the night sky. What makes T Coronae Borealis shine? As soon as the red giant has fed the accretion disk of the white dwarf to the point of reaching a critical mass, fusion processes begin, resulting in bursts of brightness. This process is known to astronomers as a recurrent nova, meaning the radiant spectacle repeats over time. This spectacle is based on thermonuclear ignition during mass transfer. A disk of hydrogen and some helium gathers on the much smaller white dwarf. Finally, the material ignites. However, this is not a fire in the sense of a classic fire but a thermonuclear combustion where hydrogen undergoes fusion reactions. Witness accounts of novae date back to the year 1217, and combined with observations recorded in subsequent centuries, experts have established that nova eruptions of the binary star have an average period of 80.7 years. The last time the stellar beacon lit up was in February 1946. The next eruption is expected in September 2024. Apart from these events, T CrB has an apparent brightness of 10.8 magnitudes, too faint to be visible to the naked eye. However, the last two novae in 1866 and 1946 had magnitudes of 2.0, meaning the binary star shone over 1,000 times brighter than usual, even surpassing Gemma, the brightest star in the Coronae Borealis constellation. As mentioned, the next nova event is already imminent, and NASA speaks of a unique observation opportunity that no star enthusiast should miss. At this point, a fundamental question arises. How can one recognize the presumed new star in the sky? The first step is to locate the Coronae Borealis constellation, a small semicircle of stars between the constellations of Hercules and Ursa Major. While it's generally advantageous to choose a dark location for night observations, in the case of the nova, a slightly brighter sky might even be helpful. In reality, seemingly better visibility can make it harder to pinpoint the desired object amid the richness of the firmament. But if you find yourself in a bright place, you'll only see the truly bright objects that stand out against the city's glare. Rotating star maps or star map apps are practical ways to track the current rising and setting times of Coronae Borealis. When you enter the observation location and corresponding time, these apps display current sky maps where you can search for specific constellations. Our perception of the cosmos can always be expanded. In our daily perception, the sun often embodies the cosmic maximum, and in relation to our solar system, this is true. But the deeper we delve into the vast expanses of space, the more our powerful host star transforms into an insignificant pinhead. If we place the giant source of heat and life next to the star Betelgeuse, for example, our Sun must admit defeat from every astronomical perspective.
Located in the constellation Orion, Betelgeuse has a diameter 800 times that of the Sun, or about 1.12 billion kilometers.
In theory, our Sun would fit 500,000 times into the so-called shoulder of Orion.
The differences in brightness are no less drastic.
Betelgeuse shines 10,000 times brighter than the Sun. Consequently, spotting this celestial body, located about 720 light-years from Earth, with the naked eye is easy. If you find yourself in the northern hemisphere during the winter months and look at the starry sky, it's practically impossible not to notice the red supergiant. Betelgeuse was already mentioned in documents dating back 2,000 years as a bright yellow-orange point in the firmament. Like all other objects in the universe, Betelgeuse is not a rigid and unchanging celestial body. Determining its radius through interferometry revealed fluctuations of about 15%. Interesting to note, Betelgeuse's radius was the first to be determined using this measurement method. However, the giant star is subject to recurring fluctuations in brightness as well. For instance, every 20-70 days, a visible brightness variation occurs. This recurring play is in turn due to the advanced phase of development that the star has reached. In short, red supergiants have the characteristic of expanding and contracting again.
Pulsation is also always linked to brightness fluctuations.
A few years ago, scientists witnessed how drastic and unsettling these changes can be. Is Betelgeuse about to become a supernova? In October 2019, experts documented a process that led to a drastic decrease in brightness. By February 2020, Betelgeuse was not even at 40% of its initial average value. Furthermore, Betelgeuse had never been so faint since astronomical studies began. But what lies behind this decrease in stellar brightness? Some experts believe that the brightness loss is simply the result of several overlapping brightness cycles. Other researchers, however, fear that the trend may be due to something much more dramatic. Betelgeuse may be on the verge of a supernova. In principle, the explosive death of a star is heralded by a strong expansion of the celestial body and a significant decrease in its brightness at the same time. However, since no star has been observed immediately before a supernova, we do not know if the corresponding dimming occurs several years or only a few hours before the explosive event. There is no doubt that one day Betelgeuse will truly make an explosive exit. According to current research, the red supergiant will bid farewell to the cosmic stage only in the distant future, as it has only recently reached its final phase. The final supernova is likely to be as far away as 1.5 million years. However, other experts have much tighter timescales and believe the giant will disappear from stellar ranks within 100,000 years. After Betelgeuse returned to its ancient splendor in April 2020, researchers deciphered the reasons for the drastic brightness decrease. In August of the same year, observations from the Hubble Space Telescope revealed that the star had expelled a giant cloud of hot, dense material. This material then cooled, condensed into dust, and shielded the emitted starlight. Due to the veil of cosmic dust, it appeared from Earth that the celestial body had drastically lost its brightness. Once an official explanation for the past evolution was found, it didn't take long for the star to reveal another mystery. Since 2023, Betelgeuse has been shining much brighter than usual. Whether Betelgeuse will explode relatively soon or not for many hundreds of thousands of years, one thing is certain. Once the red supergiant turns into a supernova, it will once again impressively remind us of the elemental forces of the universe. As mentioned, Betelgeuse already shines 10,000 times brighter than the Sun, but during its explosive death, researchers predict a further increase in brightness by 16,000 times. While some experts speculate that the star's brightness will be comparable to that of the crescent moon at night, others believe it will match the brightness of the full moon. In any case, this event would be unmissable from a terrestrial perspective. Hit the subscribe button. Join our community now to never miss another thrilling video.